My first name, last name, one word. Oh, where am I going? Yes. Oh, I thought you meant going on YouTube. Oh, I'm going to the Caribbean. Oh, wait. Oh, time out. Okay, I'm going to ask Mrs. Poon here. Who do you think has been working the hardest since September? Me or them? Who's been working hardest? Isn't it the teacher that's been working hard? Look at these guys. They goof off 24/7. What? Oh, thank you, Indian.
In one subject that you excel at, we have to take 6 subjects that we may not be the most.
I feel for you, but I've been there, done that, okay? I have been there, done that. So don't give me that stuff. Okay.
He's good at all of those.
All right, okay. Okay, let's work on this, okay? So I think what we're going to do from yesterday is we agreed that delta x, okay, delta x is going to be ci minus 1, okay? That's what we agreed on yesterday, okay? In other words, the width of your rectangle is going to be given by this. So when you look at that, you can see that ci is this, okay? So you're going to use I cubed over n cubed for that. And ci minus 1 will be the same thing, that except instead of I, it's going to be I minus 1 cubed over n cubed. You with me on that? Just like we did yesterday. Okay, just like we did for number 1 yesterday. Okay? All right, so what do I have? Now in place of f of ci, I'm going to put in cube root of I cubed over n cubed. Instead of delta x, I'm going to put this beast in here. Okay, and then this will be limit n goes to infinity, I equals 1 to n, cube root of I cubed, cube root of n cubed, n. And now what you've got to do here is you've got to FOIL this stuff. So this is going to be, this is why you were asking me yesterday, I guess, for a minus b cubed. Okay, so that's I cubed minus 3i squared plus 3i minus 1. Okay, and all this is over n cubed.
Don't you have to minus I cubed?
Sorry? I already have it right in the front there, right? So this part here is this part here. And then this guy here is this thing here. Okay? So now we're going to do our algebra here, okay? So let's go ahead and do our algebra. Yeah, that's the algebra I'm talking about. So limit n goes to infinity. I can take n cubed and n cubed and n, so that's n to the 4th. Okay, sigma I equals 1 to n, and I've got I, and I've got I cubed minus I cubed plus 3i squared minus 3i plus 1. Okay, does this make sense? Okay, so the I cubed cancel, and so it leaves me with 3i cubed minus 3i squared plus I. I distributed this I out. I distributed that I. Okay? And now you'll have to go back to page 260 in your book and pull those formulas out of page 260. Well, let's go do that, okay? So let's go. I'm going to start writing here now. Okay, so then it's going to be limit n goes to infinity of 1 over n to the 4th. Okay, now notice that when you have the formulas, the sigma sign goes away. The sigma sign goes away. So I'm going to have 3, and what's the formula for I cubed? What's the formula for sigma I cubed? Page 260. Well, if you don't know it, open your book and tell me, okay? I want to make sure we get it right, okay? Open your book, yo! Leo, dare you open your book? Yeah.
you have I cubed over n to the third, isn't it? 1, not I cubed.
I cubed over n cubed?
Isn't it 1 cubed over n cubed?
Yeah, but I pulled the n cubed out, right, to get this n to the fourth.
But where's the I cubed?
This I got distributed all the way through here. This I here, I multiplied it out in here. You want to come up here and point what you're talking about, because I'm not sure what you're saying.
I don't know, did I do something wrong in here?
I'll have to look at that later. Let me finish this. Why don't you take these notes down, and then you can kind of relate it to what you have. Okay? All right. Someone give me I cubed. Joanna. Over 6. This doesn't look very exciting to me, because I'm going to get limit go to 0 here. Huh? No, I asked for I cubed, the first one. N squared over 4. Okay? And I needed 3, right? Because of this 3 here. Right? So I need a 3 there. And then minus 3i squared. So what's the formula for I squared? N times 2n plus 1 over 6. And then what's for plus I? Thank you. N times n plus 1 all over 2. Okay? And then you're going to use the famous, now I'm going to get you girls now, okay, because this is the 3 rules. 3 rules. Okay? If you look at this guy here and this guy here, what's the degree of the numerator? 4. What's the degree of the denominator? 4. What are the leading coefficients at the top? 3. What's the leading coefficient at the bottom? 4. Right? You with me on that? Yes? It's this guy and this guy. So your limit should become 3 over 4. Okay? What's the degree of this at the top? 3. And at the bottom? 4. The limit from the rules yesterday? 0. Okay? Degree of the top? Bottom? Limit? Nice. Good job, guys. Is your answer 3 over 4? Yeah.
This is how we solve that one question.
What?
This is how we solve that one question. Like find exact.
Yes. Yes.
Can you do number 3?
Now number 3, okay, is going to be done. We're going to kind of cheat here because they're not giving us any directions about what to do with the CI. We're going to make them equal width. We'll make them equal width rectangles. Just like, did you guys take a look at number 6 sample problem that I put up on the web? Just like that. Exactly like that. Okay? Instead of doing rectangles of different widths, we're going to kind of cheat and do equal width. Because there are no directions given to us here, okay, about what to do with CI. Whereas here, you can see that they told you what to do with CI, how to write it. Okay, in 3 through 8 they didn't, so just use equal width. Yes.
What did the upper bound or the upper limit and the lower limit tell us?
What?
Like for number 3, the 10 to 4, what does that do?
Decide. You can define what the width is, right? Because 10 minus 4 is 6, so 4 is A, 10 is B. You understand that language, A and B? Yeah. So A is 4, B is 10. So your width of the area that you're looking at is 6. You're going to divvy that up into n rectangles. So each rectangle is going to be 6 over n. And then you follow the same procedure that I did in number 6. Okay, same procedure in number 6. All right? So I did put that completely worked out example, so you should have really studied that, okay? All right. Does everybody feel this theorem? Everybody feel this theorem? All the theorem is telling you is that if I want to find the area underneath the curve, all I need to do is integrate that function over the two limits. Okay? All right? So in order to find the shaded area, you integrate fx dx from a to b. All right? So no more limits, in other words. No more limits. Yeah, Tatiana, you can say it loud. Thank God. So you go to the gym wearing a tie, I see. Nice. So when you're doing those bars there, make sure your tie doesn't get wrapped around there, okay? Because that's what happens. Yeah, that's what happens. Okay, you guys got this down? Nitya, there you take notes. You know, notes are collected in this class and they count for 5% of your grade. No notes, you get a 0. Okay? Everybody got this down okay? All right, let's do examples then. So today's work is a lot easier than what you had to go through yesterday. So I'm going to do obviously a simple problem because I like doing simple things and because I'm in charge. So I want to find the yellow shaded area and my function fx is equal to 4 minus 2x. That's my function. Okay, so from the theorem that I just showed you, the area is going to be equal to integral 4 minus 2x dx. S, what's A equal to?
4. I don't know. 2. 0.
And B?
2.
2. Because A is here,
Alright.
B is there. Okay? And just do this. Integral of 4. Nice. Integral of minus 2x. Just x squared. And then you plug in 2, you get 8 minus 4, which is equal to 4. All right? And how do I find the area of the triangle using geometry from elementary school? 1/2. What is B? What is that equal to? H? Answer? 4.
Where'd you get the 8 minus 4 from?
You put in 2 here, you get 4 times 2. You put in 2 here, you get 4. Okay? Definite integrals.
Why don't you put 0?
Because then you get 0 anyway, so what's the point?
Yeah, but
4 times 0 is 0.
yeah, so why are we putting that one?
We are, but it's 0. I mean, what's the point? What's the point? The answer is still 4.
The 2 is a 0?
Sorry?
Outside bracket, do you always write the 2 as a 0? Like the
Yeah,
upper row?
upper and lower, right. Right. Okay? Guys get the idea of how to do definite integrals and find area? Okay?
Area of 1/2 times
So what you need to do is number 16. You need to do number 16. You're doing number 16. No, you're not done. You still have some more examples to do. Okay, a couple of examples, 2 more examples, and then you're done, okay? So I do number 31 and you do 27, okay? So I'm going to do 31. Okay, so I'm doing number 31. And you're going to do which one? 27?
Yep.
Okay. All right, 31. Here goes. So if you read the instructions, okay, if you read the instructions, it tells you, where are we? Sketch the region whose area is given by the definite integral, then use a geometric formula to evaluate the integral. So they're not asking you to do calculus on this one. They're asking you to use geometry. Okay? just pure art geometry. So this integral here, so to begin with, this function here, does anybody know what this function looks like if you were to graph that? Sorry? It's a what?
No, sorry, it's a line.
Okay, let's think about this. I know that y is equal to 9 minus x squared, right? How do I get rid of the square root sign? Thank you. How do you get rid of the square root sign? Square. So then the square root thing is going to be what? Half a circle, because it's only the positive side of it. Okay, so that circle is going to look like this, so semicircle is going to look like that. So everybody with me on that? This is -3, this is 3. You guys know how to find the area of that semicircle? Just do it. We can't do calculus on this until later in chapter 4. Until later in chapter 4. So we can't do calc on this. We will later in chapter 4. Okay? Right now we are only doing pure geometry. So, well, if you're doing geometry, you don't need A and B because you're not doing calculus. You're not doing calculus. Sorry? Okay, so the area of semicircle is 1/2 pi r squared.
Yes.
So that'd be 9 over 2 pi. Yeah? Okay? And then you guys are doing, and then you're doing 27, okay? You're doing 27. What's 27? Well, I guess you need to sketch that to see what 27 is going to look like. I'm not going to tell you. You've got to figure it out. Okay?
So the answer